y, and you'll say you lost your mind, right? So what was, why wasn't that going away? Okay, so did I lose you? You're still there? Okay, sorry, I for some reason I closed that window and you disappeared. I still can, okay, finally I can get back. Good. So I'm going to ask you just solve this for y, and again, as I said, you're going to tell me you probably lost your mind. There is no such thing, and I will have to agree. But what we can do is differentiate both sides, and we will be able to find an expression for dy over dx. Again, remember, this means that this is a function, and this is the independent variable. Again, this is a product, function 1, function 2. Also, this is the chain rule, because this is the outer, this is the inner. So let's start. Who would like to give us a hand?
You're going to do natural log on each side?
No, I will not be able to.
Okay.
So we differentiate the first function. What do we get?
E to the y.
Yes, because it's 1. Very good. Plus x. Now careful. How do I differentiate e to a function? Let me write it on the side again. So when we differentiate e to x, we get nicely e to x. But when we differentiate e to a function prime, we get e to that function times the function prime. If this helps you remember, then put x prime here, but that will disappear because it's 1. So I have to write e to y times y prime, but I will not write y prime. I will write dy over dx. So it's e to y times dy over dx equals. Can anyone give us the right-hand side? If this is too light of a color, tell me and I will not use it again.
Would the right-hand side be 1 minus dy dx?
Brilliant. That's it. Awesome. So now I am solving for this piece. But it is present in 2 terms. I want this one here, and I want this one here. And I want to do it in 1 step. You can do it in 2 steps if that's what you want. So this is x e to y plus 1 dy over dx. And this is 1 minus e to y. Let's stop and look at what I just did. So I moved negative dy over dx to the other side, positive dy over dx, and I also pulled out dy over dx. So I have x e to y plus 1. I had the 1, but when I move this term to the other side, it becomes negative. And it's done. I can now present the expression for dy over dx. Can anyone give us dy over dx?
1 minus e to the y over x e y plus 1.
Brilliant, thank you very much. That's it.
Question.
Yes?
How did you get rid of it? How did you get rid of the dy and dx then?
I didn't. I solved for it. This is my variable.
Right.
So if I have something times the variable equals something, I divide by this. It's like having 2x equals 4. So x equals 4 over 2. 4 over 2. 4 over 2. Is that better?
And that part of it, how'd you get rid of it on the 1 minus the dy?
That's, yeah, my issue is you're moving a negative dy dx to the other side, which would become adding dy dx to the other side.
So dy over dx times this is this.
Yes.
Dy over dx times 1 is this. Let me write it. x e to y, sorry, dy over dx plus dy over dx equals 1 minus e to y. Is this okay? Is this okay so far?
And this is where you factored out to get the x e to the y.
Exactly, because I have it in two terms.
I see.
So
Okay.
dy over dx times this is this, dy over dx times 1 is this. I have to factor it out, otherwise I can't solve for dy over dx.
Got it.
Better?
Okay. Much.
Excellent. Good, so let's go back and choose something else. Anything else we would like to illustrate with? And also, there are problems here in which we are asked, using implicit differentiation, find also the equation of the tangent line. So we're also given a point, as I mentioned before. So any of these problems, they are also showing us the graph. We don't need it, but it's a good practice just to start seeing these because they are part of calculus too. So let's choose one.
You said pick from which range?
Pick any one that you want. Did you pick and I didn't hear? Oh, I have a chat. Yep, no worries.
Can you do 34 then,
34?
please?
Yes, let's work on 34. So I'm on page 5. Let me copy 34. And then I'll stop sharing. X squared y squared equals y plus 1 squared. 4 minus y squared. And the given point is 2 to the square root of 3 comma 1. Perfect pick. Thank you. Okay, so the same thing. We're asked to find the equation of the tangent line, but I know that this is y minus y1 equals the slope times x minus x1, where the x value is 2 to the square root of 3, the y value is 1, but I don't have the slope. The slope will be dy over dx evaluated when x is 2 to the square root of 3 and when y is 1. But I need to find an expression for dy over dx first. Otherwise, I can't continue here. Without this, I can't find the equation of the tangent line. Perfect. So in order to find this, what do I have to do to both sides?
Differentiate.
Yes. So let's differentiate. So the left-hand side.
Two x y squared
Very good. So 2x y squared, brilliant, plus
x squared 2y dy dx.
excellent. Thank you very much. This is awesome. Who was that?
RJ.
Thank you. Excellent. Very good. So this is this side. Equals. I know I'd rather not continue here, so I'm going to continue here because I don't want to run out of room again. Again, the same situation. We have a product, but the product combined here with a chain rule. Who would like to help? Anyone?
2 parentheses y plus 1.
Very good. 2 parentheses y plus 1 times the inner function prime, but it happens to be 1. Very good. Times the second plus the first times the second function prime.
Negative 2y dy dx.
Negative 2y. Very good. Don't forget parentheses. It has to be in parentheses. Excellent. Times dy over dx. And I messed up here. I just realized. So 2 times y plus 1 to 2 minus 1 times the inner function prime. I rushed. Sorry about that. So times the second function plus the first function times the second function prime. So it's negative 2y, but y is a function, so it's times dy over dx. So 2x y squared, that's correct. I'm checking now because I omitted this. I want to check again. So I have 2x y squared, correct. X squared 2y dy over dx, perfect. 2y plus 1, yes. 2 minus 1, and times the inner function prime times the second function plus this times the second function prime times the inner function prime. That's it. So now we see we have dy over dx in several terms. So we have it here, we have it here, I have it in this term, I have it in this term, as well as this term. So I'm only going to move this term to the other side. This is the only one that does not have dy over dx. So 2xy squared equals dy over dx. If I can avoid writing these over and over and over, I'll try it. Okay, so let's see what we have. So if I pull this out, then I have 2y plus 1, 4 minus y squared. This goes to the other side, it becomes negative 2x squared y. And now this is negative 2y and y plus 1 squared. Yes, we can simplify this a little bit. Who cares? Really.
We can choose that on the test.
We are asked to evaluate, so I only need a number. That's why I'm not going to bother
No, you
with that.
said who cares if we don't simplify.
Because there is no need to simplify because I need a number. If I didn't need this, yes, I would have tried to simplify it. But I only need a number. So this is not the answer. So I have dy over dx, but I have to evaluate it when x equals 2 the square root of 3 and when y is 1. So if I simplify it or not, it doesn't matter. I will have to get a number. So this will be the top, 2xy squared, and the denominator is 2y plus 1, 4 minus y squared, minus 2x squared y, minus 2y, and y plus 1 squared. That's why I don't bother with it, because I have to plug in these numbers. Otherwise, I would have. But the question is not find dy over dx. No. The question is basically find the value of dy over dx and plug it in. Okay, so y is 1. So this is 1, 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 and this is 1. And this is ugly to the square root of 3. So the numerator will be 2 times 2, so it's 4, the square root of 3. And this is 1. The numerator is finished. Now let's see what we have in the denominator. 1 plus 1 is 2. 2 times 2 is 4. 4 minus 1 is 3. So that is 12. Minus 2. And x squared now is 4 times 3, which is 12. Minus 2. And this is 1 plus 1, which is 2. 2 squared is 4. So 4, the square root of 3. And let's see what we have here. So 12 minus 2 times, so this is negative 12, and this is minus 8, so this is negative 20, and I simplify by 4, and I get negative the square root of 3 over 5. This is what I need here. Negative the square root of 3 over 5. So I can double check my calculations. So 2, 4, yes. 2 plus 1, 1 plus 1 is 2. 2 times 2 is 4. 4 minus 1 is 3. 3 times 4 is 12. 2 times 1, and this is 4 times 3, which is 12. And this is 2, and this is 4. So here I just factor out 12. 1 minus 2 is negative 1. So this is negative 12 minus 8. Negative 20, yes. So this is not finished. That's why I didn't even bother to simplify. There is no need because I needed one number. It would have been silly to spend the time to simplify, but I only needed this. So y minus 1 equals negative the square root of 3 over 5 and x minus 2 the square root of 3. I have to distribute. Now I have to simplify this as much as I can. And I will distribute negative the square root of 3 over 5x here plus 2 times 3 is 6. 6 over 5 and then plus 1. So this times this is this. This times this. The square root of 3 times the square root of 3 is 3. 3 times 2 is 6 over 5. And this moves to the other side, changing its sign. And I have to find the least common denominator and multiply the top of this by 5. So y equals negative the square root of 3 over 5x plus 11/5. This is the equation of the tangent line to the point, to the graph of y at p to the square root of 3 comma 1. Very good pick. Anything else? Of course, we can also find the second derivative. So we can be asked to find the second derivative, or d2y over dx2 for different expressions. Obviously, there are equations in which we cannot solve for y. Because if I can solve for y and it doesn't take long, I'll solve for y, and I don't need implicit differentiation. But if I can't solve for y, I have no choice. So we remember the trig functions. And we discussed them last time, like sine x, cosine x, tangent x, cotangent x, secant x, and cosecant x. They also have inverses. Inverse trig functions. And the inverses also have derivatives, of course. So this will be arc sine, arc cosine, arc tangent. I'm not going to continue because I only want you to remember just these three derivatives. The rest, if we need anything, we're going to use the formulas. But these have to be remembered forever. This one is 1 over the square root of 1 minus x squared. This one, because I don't have enough room there, is the same, but with minus in front. And this one is the nicest, is 1 over 1 plus x squared. These have to be carved in stone like many other formulas. Because if we need to look these up, then we haven't learned much. So these have to be memorized. And now I'm going to share my screen.